Good afternoon, ladies and gentlemen. Today, me, Sabrina, Alexa, Stephen, and Huan Chi will be presenting our IPW project. Before we explain about our project's details, we would like you to take a look at the following slide. This here are just a few of the colors we see in our daily lives. These colors are usually associated to a certain object or feeling. For example, red is usually associated to anger, blue to sadness, yellow to happiness or optimism, and pink maybe to infatuation. Colors enrich our lives. That is why there's a pot of gold at the end of the rainbow. We conducted a survey in the whole school with a total of 375 people, and with the question, do you like colors? 90% of them answered they do. And so we added a follow-up question to that, which was, do you study with the usage of colors to help stimulate your learning? 74% of them said they do. And this was the base reason why we started for our IPW's objectives.
So why we want to make a color correction fluid? Have you wondered why other writing materials such as post-its, highlighters, pencils, erasers, and even pen, they create different kind of colors except for a correction fluid?
So in our age, where we usually need to make a more creative output for our projects, we realized that it would be best to use colored paper. But when we realized while writing on colored paper and we made a mistake, we would either cross it out or get correction fluid. But since the correction fluid we have now is only in the color white, we realized that it would destroy the overall beauty of the project.
And so for this project,
so these are the materials that we needed over here.
First is titanium dioxide. Titanium dioxide consists of titanium dioxide.
So when we first tried out that experiment, we just got a petri dish, we put some correction fluid onto it, and we just tried to put some food dye to make it mix together. But then when we tried to when it came in contact, it seemed like the correction fluid seemed to try to cover the food dye instead.
So the correction fluid was designed so that it can cover other liquids. But we didn't know what was the component, so we did a research.
So this is how the experiment looked like, and then first.
So these are the components of a correction fluid. The components colored in red are flammable components, and the components colored in green are the key of our IPW success.
So one of the components is titanium dioxide. Titanium dioxide consists of titanium and oxygen. It contains a white pigmentation that gives it the correction fluid white. So first, our plan was to change the pigmentation color into other variety of colors.
So all of these things are the components inside resin. So all of these individual components, which I know nothing about, can be separated through fractional distillation, which after we found a research. So resin is a hydrocarbon secretion of plants. So it's used widely in the production of varnishes, adhesives, and food flavoring agents. And it hardens irreversibly with the substance that it comes into contact with.
So just an analogy of resin. Imagine resin as a plastic bag in which all the other components of the correction fluid are inside it, like naphtha, titanium dioxide, and such are inside this resin. When you drop this bag into water or any other substance, obviously it won't mix with it. And this is what resin is. In a correction fluid, when you try to mix it with other substances, it will refuse to mix because of this resin, as it acts like a glazing agent. And because of that, we started to brainstorm for some separation ideas. First idea was the separation of the components through elimination. What we mean by this is because since a few of the components are flammable, we thought that if we could burn it, and then the flammable components would be consumed. And after that, we will be left with the non-flammable components. So after we obtain that residue, we would work our way to separate the rest of the materials. And that's what we mean by our first idea.
Our second idea is to change the pigmentation color of the titanium dioxide. Since we want to make it into other different colors, so we thought that we can change the pigmentation color, not only white.
Our third idea was to remove resin, put in the coloring, and put the resin back in.
And so this was our experiment steps. Do you want to do the forward? So first we got a petri dish, and then we put some correction fluid onto it. Then we got our fire gun, and we just burned it. And as you can see, it's flammable, and it starts to form like a layer of lumps above it, and then it starts to have like an ashy color. Then after a while, as you can see, the fire will slowly die, and this is because the flammable materials are being consumed. So as you can see now, it's burnt up.
So,
And when you poke it,
if you try to burn it again, it doesn't work because all the flammable materials are gone.
and if you try to poke it, if you can see, it has dried up. So this was pictures of our initial experiment. Now because of after this, we found out that even though we already removed the flammable materials, we couldn't separate the components further because we still need to remove resin. And as Hwanchi mentioned earlier, resin can only be separated through fractional distillation. So then we researched about we thought about buying a distillation machine online.
So we searched online to find out if we could purchase a distillation machine, but well, since the smallest and cheapest machine that we could find cost $100,000, which we don't have, excluding the shipping cost as well.
It's 10,000, right? It's not 100,000. Correct me if I'm wrong.
Yeah, 10,000.
I'm just wondering.
And since our school doesn't have the facility to conduct these kind of experiments, we couldn't produce a prototype.
Further, even if we were able to remove resin, we would still be needing another experiment to change the titanium dioxide's pigmentation, as Alexa mentioned, and that again requires advanced technology, and we don't have such facilities over here. So briefly, this is the features of the distillation machine we were thinking of purchasing.